NASA's Curiosity rover finds the largest building blocks of life on Mars, and scientists still don't know how they originated.
NASA's Curiosity rover, which has been exploring Mars since 2012, made a fascinating discovery in a rock sample collected inside Gale Crater.
In March 2025, scientists identified small quantities of organic molecules called decane, undecane, and dodecane, the largest organic compounds ever found on the red planet to date. These substances are long-chain hydrocarbons, similar to fragments of fatty acids, which on Earth are mainly produced by living organisms, although they can also arise from geological processes. The sample came from a region called Gediz Vallis, an ancient channel where there is evidence that water flowed for long periods in Mars' distant past. The rover analyzed the pulverized material directly in its internal laboratory, SAM, sample analysis at Mars, which heats the samples and detects the gases released. Researchers noted that these molecules were preserved in an ancient mudstone, suggesting that they survived for billions of years in conditions that, on the Martian surface, are hostile to organic matter. However, the big question that immediately arose was, how did these molecules get there? Mars currently has no known life, and its environment is characterized by intense radiation, low temperatures, and a thin atmosphere that allows the soil to be bombarded by cosmic rays. Therefore, a team of scientists conducted a complementary study, published in February 2026 in the journal Astrobiology. They combined laboratory experiments with radiation, mathematical modeling, and data from Curiosity to go back in time about 80 million years, the period when that rock was exposed on the surface before being protected. The results were surprising. Known non-biological sources, such as meteorites falling on Mars bringing organic material or purely geological chemical processes, cannot explain the observed quantity of these molecules. Even considering the gradual destruction caused by radiation, the original abundance would have been much greater than what these mechanisms could realistically produce.
This doesn't mean that life existed on Mars. Scientists are cautious and emphasize that it's not yet possible to conclude whether the molecules have a biological origin or not. What the study shows is that the non-living processes we know are not enough to justify everything that was found. There may be other unknown chemical mechanisms on Mars, or a contribution from processes involving ancient life, such as microorganisms that lived when the planet was wetter and more habitable, more than 3 billion years ago. This discovery adds to other evidence accumulated by Curiosity over the years. The rover had already detected simpler organic molecules in mud rocks in the same crater, as well as signs that there were lakes, rivers, and even seasonal variations of methane in the atmosphere. Together, these findings paint a picture of an ancient Mars very different from the current one, warmer, with liquid water and conditions that, in principle, could have allowed the emergence of life. Even so, proving the existence of past life is extremely difficult. Organic molecules can come from many sources, and Martian radiation rapidly destroys or alters these compounds. Therefore, researchers emphasize the need for further studies, including experiments that better simulate real Martian conditions over extended periods. Future missions, such as the return of samples collected by Perseverance or new probes capable of analyzing the Martian subsurface, will be essential to clarifying this enigma.
Meanwhile, the discovery fuels scientific curiosity about whether we are alone in the universe. Finding building blocks of life on another planet, especially in quantities that defy purely non-biological explanations, reinforces the importance of continuing to explore Mars. Curiosity, which has already far exceeded its planned mission, continues to send back valuable data as it advances to new regions, such as areas with patterns called boxwork, that may reveal even more about the planet's wet past. In short, the Curiosity rover detected the largest organic compounds ever seen on Mars, and detailed analysis indicates that known non-biological processes do not fully explain their presence. This opens an intriguing door to the possibility that ancient biological processes may have contributed, although nothing is proven. The search for life on Mars, or traces of it, continues, step by step, driven by tireless robots and human imagination.